Hi everyone, hope you all are good. We are here for grade 5 math. You can find all the lessons on aplusstudents.com. You have to log in there using your email address and password is provided by the administrator. Then you have to select math from the subject tab. Scroll down to grade 5 and then click on view all lessons. So there you can find a list of the chapters. We're going to start with the chapter triangles and quadrilaterals. And the lesson we're going to cover today are classify quadrilaterals, properties of triangles and quadrilaterals. Then we're going to start the new chapter, that is symmetry and transformations. And the lessons are lines of symmetry, rotational symmetry, reflection, rotation, and translation. So let's just start with the first lesson. Okay, here I'm on grade 5 math. So let's just start with the chapter triangles and quadrilaterals. Here is the chapter triangles and quadrilaterals. Let's just start with the lesson classify quadrilaterals. Okay, is this shape a parallelogram? You are given a four-sided shape. You need to see if this is a parallelogram. So no, this is not a parallelogram. Why? Because the opposite sides are neither parallel nor triangle. So in a parallelogram, the opposite sides must be parallel or congruent. So in the given shape, they are not neither parallel nor perpendicular. So this one is not the neither parallel nor congruent. So this is not the parallelogram, right? Okay, the next one is this shape a square? No, this is not a square because square has all four right angles. So the in the given one they are not the right angle triangle. It does not have a four right angles. So this one is not a square. So that means if a shape is a square, all the four angles must be right angles. Okay, is this shape a square? No, this is not a square because it does not have a four right angles and because it has sides that are different length. You can see opposite two sides have different lengths. So that means this is not the square. Square have all four sides equal in length. Let's just start with the practice questions. Okay, is this shape a parallelogram? Yes, this is a square and parallelogram as well because opposite sides are congruent and parallel. So it is a parallelogram. Is this shape a rectangle? Yes or no? No, this is not a rectangle. This is a triangle. It is a three-sided shape, so it is a triangle but not rectangle. The correct option is no. Okay, is this shape a square? You are given a four-sided shape. You need to see if this is a square. So which is the correct option? Yes or no? No, this is not a square because a square has all four sides equal in length. So this is not a square. Okay, the next one is this shape a square? Which is the correct option? Yes or no? No, this is not the square because square has all four right angles. So this is not a square. The correct option is no. Okay, is this shape a rhombus? Yes or no? The correct option is no. This is not a rhombus. Okay, the next one is this shape a trapezoid? So which is the correct option? Yes or no? No, this is not a trapezoid, so the correct option is no. Is this shape a rectangle? The correct option is no, this is not a rectangle. Is this shape a parallelogram? So, which is the correct option? No, this is not a parallelogram. This is a three sided shape. This is not a parallelogram. Is this shape a parallelogram? Which is the correct option? Yes or no? No, this is not a parallelogram. The correct option is no. Is this shape a square? Which is the correct option? No, this is not a not a square, because a square have all four angles that are right angles. So for this one, they are not the right angles. So no, this is not a square. Okay, we are done with the lesson. Let's just start with the next one. Okay, the next one is properties of triangles and quadrilaterals. So let's just start with the next lesson. Now we're going to learn what are the properties of triangles and quadrilaterals. So the first example is Zach cut a shape out of a piece of construction paper. The shape had four sides with opposite sides parallel. Which shape can could Zach have made? So you're given the four options. Cut a shape. Okay, shape had four sides with opposite sides parallel. Which shape could Zach have made? So which shape which is the correct option? Opposite sides are parallel. So you have only one four-sided shape here, that is a parallelogram. That means the correct option is parallel. Just look at the options carefully. You can see three sides, three sides, three sides. Only one of them have four sides, so that would be a parallelogram. That means Zach made the parallelogram. Got it? Okay, the next one is Jack cut a shape out of a piece of construction paper. The shape had three unequal angles. Which shape could Jack have made? So, which is the correct option? You can see you have four options given. You have three options for the three sided shape, one, two, and three, but three unequal angles. The unequal angles are in the scale and triangle. Got it? Because you can see one of them is isosceles triangle, then quadrilateral triangle have all three angles equal in Mayer. Then isosceles has two triangles, so scale has all three angles unequal. That means the correct option is scale triangle. Jack could have make the scale triangle, right? Okay, the next one is Nate painted a shape. Nate painted a shape that had two acute angles and two obtuse angles. Which shape could Nate have painted? Okay, two acute and two obtuse. That means that is a four-sided shape, because two and two four angles, so that would be a four-sided shape. So you have two four-sided shapes. One of them is rectangle and then trapezoid. Triangle has all the right angles. Rectangle has all four angles that are a right angle, but trapezoid has two acute and two obtuse. That means Nate could have painted a trapezoid. Got it? Let's just start with the practice questions. Okay, Zach cut a shape out of a piece of construction paper. The shape had four sides with opposite sides parallel. Which shape could Zach have made? Okay, you are given the four options. The shape had four sides. Okay, so you can see all the four options carefully. Just one of the shape have four sides, and that would be a parallelogram. That means Zach could have made the parallelogram. The correct option is parallelogram, right? The correct option is parallelogram. Okay, May used a crayon to draw a shape on a piece of paper. The shape had four square corners. Which shape could May have drawn? So, which is the correct option? Just look at the options carefully. So, you are given four shapes. Three of them are three-sided shapes. Only one of them have four sides. So that means the correct option is rectangle. Rectangle is a four-sided shape. The correct option is rectangle. Okay, Nate painted a shape that had two acute angles and two obtuse angles. Which shape could have Nate have painted? Which is the correct option? Two acute and two obtuse. You can That means that is a four-sided shape because you have four angles. So you can see two of the shapes have four angles, rectangle and trapezoid, but rectangle have all the angles that are right angles. So that means that would be a trapezoid that has two acute angles and two obtuse angle. That means Nate could have made the trapezoid, right? The correct option is trapezoid. Okay, the next one is Jack cut a shape out of a piece of construction paper. The shape had three unequal angles. Which shape could Jack have made? So, which is the correct option? They are the questions awaited on the tutorial. So, if you already know the answers, you can please write down the answer in the chat box. Which is the correct option? Three unequal sides. You have three shapes with three sides. They, they are isosceles triangle, scalene triangle, and equilateral triangle. So, which is the correct option? The correct option is scalene triangle because equilateral triangle have all three angles equal in Mayer. Isosceles triangle have two angles that are equal in Mayer, but the scalene triangle is the one that has all three angles, all three unequal angles. That means the correct option is scalene triangle. So the correct option is scalene triangle. Sarah used a crayon to draw a shape on the paper. The shape has three equal angles. Which shape could Sarah have drawn? Okay, three-sided shape it is, and all three angles are equal. So, which is the correct option? You have four options given. That means that would be three. Just two of the options have three sides. So, which is the correct option? The correct option is equal angles. So, equilateral triangle is the one that has all three angles equal in Mayer. That means the correct option is equilateral triangle. So the correct option is equilateral triangle. Okay, we are done with the lesson. Also, we are done with the chapter triangles and quadrilaterals. So let's just start with the next chapter. Okay, here I am on grade 5. Which chapter is the next? We're going to start the new chapter that is symmetry and transformations. So let's just start with the next lesson. Okay, let's just start with the first lesson, that is lines of symmetry. So here I am on the lesson line of symmetry. So what is a line of symmetry actually? The line of symmetry is the one if you fold the given picture, the two sides will exactly match. If the two sides will exactly match up, that means the figure has the line of symmetry. The dotted line means the dotted line you created is the line of symmetry. Just look at the first example. Is the dotted line a line of symmetry? You made a dotted line. Now you are going to see if the line is a line of symmetry. So if you imagine folding the picture along the dot line, so when you fold, the the two sides will match up exactly. That means the dotted line is a line of symmetry. The correct option is yes, the dotted line is a line of symmetry. Okay, here is another example. Is the dotted line a line of symmetry? Line of symmetry means if you cut a picture into two exactly, if you cut the picture into two pieces, the two pieces exactly match up. Got it? So just imagine folding the picture along the dotted line. If you fold them, the two sides will match up exactly. That means the line is that the dotted line is a line of symmetry. Okay, the next one is the dotted line of is the dotted line a line of symmetry? No, the shape, if you fold the shape along the dotted line, the two sides will not match up. That means the dotted line is not a line of symmetry. Got it? Okay, now you can make another dotted line, and if you fold the image along the dotted line, the two sides will exactly match up according to this line. That means this is the line of symmetry, right? Let's just start with the practice questions. Okay, is this line of symmetry, which is the correct option? Yes or no? Is the dotted line a line of symmetry? No. If you fold the shape along the dotted line, the two they don't exactly match up. That means this is not the line of symmetry. So the correct option is no. Okay, the next one is the dotted line a line of symmetry, which is the correct option? Yes, it is a line of symmetry. Imagine folding the shape along the dotted line. The two sides exactly match up. That means yes, this is a line of symmetry. So the correct option is yes. Is the dotted line a line of symmetry, which is the correct option? Yes or no? The correct option is yes. If you fold the image along the dotted line, the two sides exactly match up. That means yes, the dotted line is a line of symmetry. The correct option is yes. Is the dotted line a line of symmetry, which is the correct option? The correct option is yes, it is a line of symmetry. If you fold the image along the dotted line, the two sides match up. So the correct option is yes. Is the dotted line a line of symmetry, which is the correct option? No, the dotted line is not a line of symmetry. So the correct option is no. Is the dotted line a line of symmetry, which is the correct option? The correct option is no. The given line is not a line of symmetry. Is the dotted line a line of symmetry? Yes, the dotted line is a line of symmetry. The correct option is yes. Is the dotted line a line of symmetry? Yes or no? No, this is not a line of symmetry. The correct option is no. Is the dotted line a line of symmetry? Yes, it is a line of symmetry. If you imagine folding the shape along the dotted line, the two sides exactly match up. So that means the correct option is yes. Is the dotted line a line of symmetry? The correct option is no. Is the dotted line a line of symmetry? The correct option is yes. The dotted line is a line of symmetry. Is the dotted line a line of symmetry? The correct option is no. The dotted line is not a line of symmetry. Is the dotted line a line of symmetry? The correct option is yes, it is a line of symmetry. Is the dotted line a line of symmetry, which is the correct option? The correct option is no. The given line is not a line of symmetry. Is the dotted line a line of symmetry? The correct option is yes, it is a line of symmetry. If you imagine folding the shape along the dotted line, the two sides exactly match up, so that would be a line of symmetry. The correct option is yes. Okay, we are done with the lesson. Let's just start with the next lesson. And the next lesson is rational symmetry. Let's just start with the next lesson. Okay, does the picture has rational symmetry? No. If you rotate the picture half turn or less, it will not exactly the same. It will not look exactly the same. The picture does not have rational symmetry. So what is rational symmetry? Rational symmetry means if you rotate a picture by half, it looks like the same. Then that means they have the rational symmetry, right? Okay, the next example is, does the picture have a rational symmetry, which is the correct option? The correct option is no. If you rotate the picture half turn or less, it will not exactly the same. So that means the picture does not have the rational symmetry. Okay, the next one is, does the picture have rational symmetry? Yes. If you rotate the image by half, the image looks like exactly same. So that means yes, it have a rational symmetry. So the correct option is yes. Let's just start with the practice questions. Okay, does this picture have a rational symmetry? So which is the correct option? The correct option is no. If you rotate the image along half or less, the picture do not looks the same. So that means no. The correct option is no. Okay, the next one is, does this picture have a rational symmetry? Which is the correct option, yes or no? The correct option is yes, because if you rotate the picture by half, it will have a rational symmetry. So the correct option is yes. Does this picture have a rational symmetry? The correct option is yes, it have a rational symmetry. Does this picture have a rational symmetry? Yes or no? The correct option is no. If you rotate the image along half or less, it doesn't looks like same. So no, the correct option is no. Does this picture have a rational symmetry? The correct option is no. The correct option is no. Oh, sorry. Yes, it the picture have a rational symmetry. If you move the picture along half or less, it will have. It looks like same. So yes, it has a rational symmetry. The correct option is yes. Okay. Does this picture have a rational symmetry? So which is the correct option? The correct option is no. Does this picture have a rational symmetry? The correct option is no. Does this picture have a rational symmetry? The correct option is yes. Does this picture have rational symmetry? The correct option is yes. Does this picture have a rational symmetry? The correct option is no. Okay, you can complete the test by yourself later today. Let me just move on to next lesson. Okay, the next one is reflection, rotation, and translation. Okay, let's just start with the next lesson, that is reflection, rotation, and translation. Okay, what combination of transformations is shown below? Okay, you have to start from one, shape one, then you have to look for shape 2 and 3. You need to see what type of translations you have applied from shape, moving from shape 1 to shape till shape 3. Okay, so use a translation to turn shape 1 into shape 2. Okay, so how do you turn shape 1 into shape 2? You did a translation means you moved the whole thing from here to here. All the four coordinates are changed. In that case, that would be a translation. You can see here, from you move from here to here. Now this one has the new coordinates. Got it? The image show a translation to shape, the shape down 5 and right 7. You moved shape down 5 squares and right 7. Got it? Okay, now from 2 to 3, this is just a rotation. You just rotated from this corner. You move from here to here. So the image shows the rotation. Rotate the shape 90-degree clockwise. That is a 90-degree clockwise rotation. So to go from shape 1 to shape 2 to shape 3, use a translation and then a rotation. First you translate it and then you rotate it, right? Okay. What combination of transformations is shown below? Okay, you started from 1, then 2 and 3. So from 1 to 2, that would be a rotation. Got it? The use a rotation to turn shape 1 into shape 2. The image shows a rotation. Rotate the shape 90-degree clockwise. That is a 90-degree clockwise rotation. Then from 2 to 3, you moved the complete thing from here to here. That would be our translation. Use a translation to turn shape 2 to shape 3. The image shows a translation. Translate the shape down 4 and right 1. You move down 4 squares and right 1. So that would be a, first you used a rotation and then a translation, right? Okay, the next one is, what combination of transformations is shown below? 1, 2, and 3. So which is the correct option? Use a rotation to turn shape 1 into shape 2. Okay, you have to move from shape 1 to shape 2. That would be a rotation. Then from 2 to, that would be the reflection. You just reflected. Use a reflection to turn shape 2 into shape 3. This image show a reflection. Reflect the shape across the horizontal line. So that would be just a reflection. One of the side is same. That would be just a reflection, right? So we've learned three things here: rotation, translation, and reflection. If you move the whole shape from one place to another, that would be a translation. If you just move from one side to another side, like this one, that is just a rotation. From one corner, you move from one corner is exactly the same, so that would be just a rotation. And for the reflection, that is just like if you see the shape in the mirror, the one, two is, and three are opposite, so they are the reflection. Let's just start with the practice question. Okay, what combination of transformations are shown? Okay, from 1 to 2 and 3. 1 to 2. 1 to 2 is the reflection. 2 to 3 is a reflection. Okay, no. 1 to 2 is a reflection. 1 to 2 is a translation, and 2 to 3 is a reflection. The correct option is the fourth one. From 1 From shape 1 to 2, that would be a translation, and from 2 to 3, that would be a reflection. Wrong answer. Why? Okay, reflection. 1 and 2 is a reflection. From 1 to 2, that would be reflection, and from 2 to 3, that would be a rotation. 180-degree rotation it is from 2 to 3. Okay, right. Okay, got it. Okay, what combination of transformations is shown below? Okay, from 1 to 2, that would be rotation, and 2 to 3, that would be a reflection. So that is rotation. First you rotate it and then you reflect it. That would be rotation and then reflection. Okay, what combination of transformations is shown? Okay, from 1 to 2, 1 to 2, that is a rotation, and 2 to 3, that would be a translation. So it is rotation and then translation. First we rotate it and then you translate it. So that is rotation and translation. Okay, what combination of transformations is shown below? Okay, 1 and 2. 1 and 2 are the reflection of each other. So that is a reflection and then a rotation. So it would be reflection and a rotation. Right? 1 and 2 are the reflection of each other, and 3 is the rotation. So they are reflection and then rotation. What combination of transformations is shown below? From 1 to 2, that is a translation. But 1 and 2 are the reflection and then translation. So it would be reflection and then translation, because 2 to 3 is a translation. Okay, what combination of transformations is shown below? 1 to 2. 1 to 2 is the translation, and then 2 to 3 is the rotation. So they are translation and then rotation. Yes, translation and then reflection. 2 and 3 are simply opposite to each other, so they are the reflection, right? Okay, from 1 to 2, that would be a rotation, and 2 to 3, that would be a translation. So it would be rotation and then translation. Okay, 2 to 3, rotation and reflection. Okay, 1 to 2, that would be a translation, and then 2 to 3, that would be a rotation. Translation and then rotation. Okay, what combination? 1 to 2 is a rotation, and 2 to 3 is the translation. So rotation and then translation. Okay, you can complete the rest of the questions by yourself later today. So we were working on grade 5 maths. We have started with the lesson, with the chapter triangles and quadrilaterals. The lessons we have done today is classify quadrilaterals, properties of triangles and quadrilaterals. Then we have started the new chapter, that is symmetry and transformations. And the lessons we have covered are line of symmetry, rotational symmetry, and reflection, rotation, and translation. So please make sure before the next session you can complete all the test questions for the lessons we did today. So if you need more help with any of the lesson, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. So that's all for today. See you in the next session. Bye, everyone.